Since the mid-1920s, Douglas has been a prominent name in the world of aviation. Between 1922 and 1997, the Douglas Company, then the Douglas Aircraft Company, and then McDonnell Douglas produced aircraft in all shapes and sizes. Some were well-known record-setters, like the Douglas World Cruiser. Some have been immortalized in the aviation halls of fame, like the legendary DC-3. Some were hugely innovative, contributing much to the field of aeronautical engineering, like the XB-19. And some earned themselves a bit of a poor reputation due to a combination of questionable design choices, near-criminal executive decisions, and some appallingly bad luck. Many more are simply not well known, or more or less forgotten, but each of them plays a part in the Douglas story. But it isn't just all about the planes though. Today's video will cover the history of Douglas in general, the history of the company's founder, and how the company fortunes were not just shaped by the success of its aircraft, but also by world events, politics, finance, and the ever-competitive nature of the aviation industry. Today's topic was also voted on by the channel supporters over on Patreon, who I must offer a sincere apology to, as this was voted on way back in early May, and I'm now recording this at the beginning of August. However, the plan was originally to make just a 30-minute video, and it's now evolved into something like a 3-hour-long multi-part epic, so hopefully this is worth the wait. Additionally, as a quick aside, this video will not cover the history or the aircraft bearing the McDonnell name, as that will be coming in its own dedicated video in the future. So, let's start at the beginning with Donald W. Douglas. He was born in Brooklyn on the 16th of April 1892, the second son to William Douglas, who was an assistant cashier of the National Park Bank. He received his early education at the Trinity Chapel School in New York, and then at the age of 17, having developed a love for the sea, he followed in his older brother's footsteps and attended the U.S. Naval Academy at Annapolis in the autumn of 1909. But as history is about to tell, his time with the Navy would be rather short-lived. Douglas was already developing a fascination with aviation. He was enthralled by the flying machines of the Wright brothers, and the reports of those being built in Europe as well. As a result of this fascination, he spent much of his spare time building model aeroplanes. Some were powered by crude motors, and others by rubber bands, and he could often be seen testing them on the open grounds of the Naval Academy. The result was that in 1912 he decided to resign as a midshipman before graduating and pursue a career in aeronautical engineering. Now in later years, some of Douglas's friends would claim that another motive for him leaving the academy was that one of his model aeroplanes almost took out an admiral who happened to be walking the grounds one morning, which led to some understandable drama. But Douglas himself repeatedly denied this story for his entire life, so it's difficult to say how much truth is in this particular tale, but regardless it has become part of the Douglas myth/legend. After leaving the academy, Donald Douglas attempted to obtain his first job in the budding American aircraft industry. He applied to work with both Grover Loening and Glenn Curtiss, but both of them turned him down. This did not put him off though, and he enrolled as a student in aeronautical engineering at MIT. Among his professors was Jerome Hunsaker, and I apologize if that was pronounced incorrectly. He had also been to the academy at Annapolis, but he had actually graduated, and he would later go on to serve as the chief of the Navy's Bureau of Construction and Repairs Aircraft Division. Hunsaker had created the nation's first aeronautical engineering program at MIT, and after Douglas graduated with his diploma in 1914, he remained on as Jerome's assistant for just over a year. But Douglas soon tired of teaching aeronautical engineering, as he actually wanted to actively do it, and so in 1915 he left MIT to join the Connecticut Aircraft Company as a consultant. There, he assisted in the design of the DN-1, the first dirigible for the US Navy, but his stay at the company would be brief. In August of the same year, he joined the Glenn Martin Company as chief engineer, and he worked on a number of their designs. Most notable was the MB-1 and its derivatives. Now, the MB-1 was the first purpose-built bomber produced in the United States, and Douglas also had a hand in designing some of its subvariants, such as the T-1 or GMP, which was a transport version, and he also designed the TM-1, which was a navalized version. Of these, the T-1, the transport version, held his interest the most, as Douglas was among a group of emerging aircraft designers who was beginning to grasp the future importance for commercial aviation. But as fate would have it, his ambitions in this department would not actually be realized for a great number of years. Douglas enjoyed a very successful 4-year career with Glenn Martin, where as chief engineer he would eventually be earning a salary of $10,000 by 1920. He was also now a family man. As the Glenn Martin Company went through a consolidation in 1916 to form the Wright-Martin Company, Douglas had a brief stint as the Chief of Aeronautical Engineering at the Army Signal Corps, during which time he met his future wife, Charlotte, in California. By the end of the year, he was back working for Glenn Martin again, and the newly married couple resettled in Cleveland, Ohio. But despite his success, working for Glenn Martin didn't satisfy Douglas's near-on obsessive desire for aircraft design, particularly as he was not his own boss and didn't have complete creative freedom. Additionally, working for the company had meant that he and his family had to live in Cleveland, and Douglas and his family much preferred the warmer climate of California. Because of this, at the start of 1920, Mrs. Douglas and their 2 sons relocated down to Los Angeles, and Douglas made plans to follow them. Leaving a $10,000 job in 1920 with just $600 in savings was a risky move, but Douglas was determined to design and build aircraft himself, and once he'd settled down in LA, he wrote to his old mentor, Jerome Hunsaker, and expressed his desire to find some investors. Douglas wanted to establish a company that produced commercial aircraft. He believed that California was one of the best places for commercial aviation to get started in the States, particularly as its climate was more conducive to testing aircraft rather than the often stormy and unpredictable winds of the East Coast. Hunsaker didn't share Douglas's optimism, and he suggested that Douglas go to Seattle and join William Boeing, something that Douglas outright refused to do. Indeed, the Douglas-Boeing rivalry is a topic that will get its own video in the future. But Hunsaker also lamented that the US Navy was being deprived of Douglas's skills in designing aircraft. And so, as a financial and as a moral compromise, as he still had to put a roof over his family's heads, Douglas continued to do contract work for the US Navy whilst he attempted to find investors for his own plans. A few months later, as money was starting to run out and as Douglas was beginning to give up hope for his endeavours, an old work colleague from Glenn Martin, Bill Henry, came in and saved the day. Bill had for a time been the advertising manager for Glenn Martin, and he now worked as the writer for the Los Angeles Times. He introduced Douglas to somebody called David R. Davis, a sportsman who had developed an interest in aviation, and, more importantly, someone who had quite a lot of money. Davis didn't share Douglas's passion for producing commercial aircraft, but he was prepared to enter into business with him, providing over $40,000 in capital, if Douglas designed and built him an aircraft, because he wanted to attempt the first non-stop crossing of the continental United States. Douglas agreed to this proposal, and on the 22nd of July 1920, the Davis-Douglas Company was officially formed. The nucleus for what would eventually go on to become the juggernaut that was Douglas Aircraft, and then McDonnell Douglas, had a very humble beginning, working out of a rented room in the back of a barber shop on Pico Boulevard in Los Angeles. In this cramped room, Douglas began the design work on the first aircraft that could be truly called his own. He was soon joined by 5 former colleagues from the Glenn Martin Company as well: George Borst, Ross Elkins, James Goodyear, Henry Guerin, and George Strumpel. At the same time as this, they had to find space to actually build Davis's aircraft, and the company ended up renting the loft of the coal planing mill in downtown LA, and it was here that construction on what would soon become known as the Douglas-Davis Cloudster began. The aircraft got its name from Eric Springer, who joined the company as its first test pilot, and, upon seeing the aircraft, he'd said, "My, you've got yourself a real cloud duster there, Doug," and the name stuck. The Cloudster was a fairly typical post-war American biplane, but one built with an emphasis on range. The airframe was constructed of wood, with the forward section of the fuselage covered in veneered panels, and the rest being covered in doped fabric. It was a single-bay tractor design that was powered by a 400 horsepower Liberty V12 engine that drove a two-blade wooden propeller. Compared to other designs at the time, it had quite a large fuselage, and this was to house the two fuel tanks that totaled 660 US gallons, or just under 2,500 litres, as well as a 50-gallon oil tank as well. The combined fuel load was to give the Cloudster an estimated range of 2,800 miles, or 4,505 kilometres, and behind these tanks, almost halfway back along the entire fuselage length, there was an open cockpit which was wide enough to allow two people to sit side by side. Now, producing the components for the Cloudster in their rented loft was one thing, but building the aircraft there may have presented a bit of a challenge, as, well, it's a rented loft. As ripping the entire roof off the building and craning out a completed plane was obviously out of the question, the parts were taken in piecemeal and lowered to the ground floor via an elevator shaft, with the team collectively holding its breath as the delicate wings and control surfaces were gradually hoisted down. Once everything was on the ground in one piece, it was loaded into trucks and taken off to one of the airship hangars in Goodyear Field, and the aircraft found itself assembled by mid-February of 1921. The Cloudster's first attempt at its maiden flight was almost its last. The airstrip of Goodyear Field was quite short, and even though it was lightly loaded, Eric Springer was forced to abort the takeoff by intentionally putting the Cloudster into a ground loop before crashing into a copse of trees. Fortunately, the damage was quite light, and it was repaired in about 2 days. It then made a successful maiden flight on the 24th of February, with Eric Springer and Douglas Davis taking it up for a calm and completely uneventful flight that lasted approximately 30 minutes. Following this, Springer and Davis took it up for a series of test flights in March to determine the optimum cruising performance, and on the 19th, the Cloudster broke the Pacific altitude record by climbing to 19,160 feet. Finally, in June, they were satisfied that the aircraft was ready for the attempt to fly across the United States, and a departure point was set at March Field in California, with an arrival destination to be made at Curtiss Field in Long Island. As the first hour or so of the flight was expected to be quite slow, owing to the very heavy fuel load, takeoff was to be set at the crack of dawn to make use of the maximum amount of daylight as possible. For several days, the flight had to be postponed due to early morning fog at March Field, which was a seasonal event that delayed many a morning flight during this time period, but finally, on the 27th of June, the fog cleared early enough to allow a takeoff at 6 a.m. The flight began smoothly, and by midday, Springer and Davis were at 6,000 feet above Tucson in Arizona. But their luck then failed them over Texas. The engine's timing gear failed, and Eric Springer was forced to make an emergency landing at Fort Bliss. Within 3 weeks, parts had been sent out and temporary repairs had allowed the Cloudster to go back to March Field, but by this point, Davis had lost interest in making another attempt. Douglas, meanwhile, had secured a contract for the Navy to produce 3 torpedo bombers, which we will cover shortly, but Davis had no interest in financing military aircraft, or any other kinds of aircraft for that matter, and he withdrew his financial support within a few weeks. Without the financial backing of Davis, Douglas was forced to dissolve the fledgling company, and he once again turned to his friend Bill Henry for assistance. With the guaranteed partial payments supplied from the Navy for their torpedo aircraft, he only needed around $15,000 to launch a new company and begin construction on the military prototypes. However, Douglas was still a relatively unknown name in the aircraft industry, in the grand scheme of things, and bankers were not quite prepared to provide the needed funds. Bill Henry, on the other hand, had faith in Douglas, and he introduced him to his employer, Harry Chandler, who was the publisher of the Los Angeles Times. Chandler was interested in promoting new business ventures in Southern California, his journalistic realm, and he agreed to co-guarantee a bank loan of $15,000, if Douglas could find 9 other businessmen who were willing to do the same. Clearly, Douglas had some sort of a good reputation by this point, as he obtained the required business signatures within just a few days. The loan was organised, and in July of 1921, the Douglas Company was formed. Before we get into the history of the Douglas Company, though, there is still more to the story of the Douglas Davis Cloudster. Having sat idle for over a year, and taking up some valuable storage space, it was sold to a couple of Californian businessmen. T. Kinney and B. Brodsky wanted to use it for charter flights above their Venice Beach resort, and they commissioned Douglas to extensively modify the aircraft for their needs. The extra fuel tanks were removed, and as the fuselage was big enough, accommodation was made for 5 passengers and a pilot in 3 rows of open cockpits. Though nominally rated for 6, on some occasions extra passengers were crammed into the first 2 cockpits, which technically raised the total seating to 10, though it was a bit of a squeeze. In the end, this business scheme didn't last very long, and in 1925 the Cloudster was sold on again to T. Claude Ryan, who was establishing an airline to connect Los Angeles and San Diego. The Cloudster began operations on the 1st of March 1925, becoming one of the first scheduled passenger lines in the country, but it only fulfilled this role for less than a year. During this brief time, the aircraft was modified when it had to be repaired after a landing accident. The pilot's open cockpit was moved forward to a position just beneath the wing leading edge, and a new enclosed cabin for 10 passengers was installed behind it. A test flight then showed that the pilots were quite literally being poisoned by the proximity to the engine exhaust fumes, and an exhaust stack was then installed. This was later followed by the installation of a new circular radiator to improve takeoff performance, and with these changes in place, the Cloudster continued its brief career with Ryan. The improved performance gleaned from the design changes would serve the Cloudster well when, after the demise of the airline, it found itself being used for an impromptu beer supply mission. Not long into the era of Prohibition, many towns across the US-Mexican border were making a tidy profit out of those who crossed the border for a drink. But just before Christmas of 1926, heavy rains had washed out the main roads that connected to the town of Tijuana with its supplier of beer. Not wishing to disappoint their eager patrons, and not wishing to miss out on a serious amount of Christmas cash, the various bars of the town banded together and chartered a series of aircraft. Among the aircraft selected was the Cloudster. During the height of its aerial beer run, which saw the Cloudster crammed to the brim with kegs, it was then diverted for a chartered passenger flight, as the floods had washed out many main roads. Unfortunately, the pilot, who was flying it from Tijuana to Ensenada, had to attempt a night landing on the beach, and he rather miscalculated it and put the wheels down in the sea. Thankfully, it was right near the beach, so the water was shallow, but it did produce enough drag that the aircraft nosed over. Thankfully, both pilot and passenger made it out of the aircraft unharmed, but the tide was rising, and that night it completely consumed the poor, stranded Cloudster, and its story came to a soggy and damp end. Now, with the anticlimactic saga of the Cloudster concluded, we'll return back to 1921. Not long after the Davis-Douglas Company was reformed into the Douglas Company, it had received a contract for what would become the first military aircraft to bear the Douglas name, and it marked the beginning of a long and fruitful working relationship between Douglas and the US Navy. Douglas had heeded the advice of his old friend and mentor, Hunsaker, who was now a commander in the US Navy, and when said Navy had sought out designs for its first dedicated torpedo bomber, Douglas got to work and drew up a proposal. What would become known as the DT-1 was quite similar to the Cloudster, sharing its thick struts and somewhat slab-sided appearance, but there were differences. For one thing, the Cloudster had an all-wood structure, whereas the DT-1 would be made of mixed construction. The fuselage was built in 3 sections. The forward and center sections had a structure of welded steel tube that was clad in aluminium coverings, and the rear section was a steel structure covered in doped fabric. The horizontal tail surfaces were also made from welded steel tube with fabric coverings, but the structure on the vertical fin, as well as the wings, was made of wood. As originally proposed, the aircraft was a single-seat design. It could be equipped with either a wheeled undercarriage or floats. It had folding wings, and it would carry a 1,835-pound torpedo in a recess beneath the fuselage. After completing the plans for the aircraft, Douglas went to Washington to submit his proposal, and on the 14th of April 1921, his first military contract was awarded, ordering the production and testing of 3 experimental aircraft to be designated as the DT-1. The first DT-1 was completed by October of 1921, and it was powered by a 400 horsepower Liberty engine. At the time of its completion, the DT-1 was fitted with twin floats, but for its first flight this was changed out to a wheeled undercarriage. Eric Springer took it up for its first flight in early November, and on the 10th of that month, he then flew it onto the Naval Air Station in San Diego for its acceptance trials. These trials were completed without incident, with both wheels and floats, by the end of December of 1921. Though the DT-1 was remarkably successful for a first attempt, in that pretty much nothing went wrong during its entire trialing period, the Navy was not fully satisfied. Or rather, the naval pilots weren't fully satisfied. It was felt that a torpedo bomber would need a crew of 2, or perhaps even 3, to be practicable. Currently, the pilot was being forced to manage the handling of the aircraft, the navigation of the aircraft, and the operation of the torpedo in combat conditions. Additionally, this meant that the torpedo bomber in its current configuration was defenseless, and a second position for at least a gunner was highly recommended. Based on this feedback, the Navy instructed Douglas to modify the second and third prototypes accordingly. To accommodate a position for the observer/navigator/gunner, the pilot's cockpit was moved forward to a position immediately beneath the upper wing. The new second position was then placed just behind the trailing edge of the wing, and it came with a single 30 caliber machine gun on a flexible mount. These changes were submitted and subsequently approved, and the second and third DT-1s were modified and completed in early 1922, being redesignated as the Douglas DT-2. It was fortunate for Douglas that 3 of these aircraft had been specified by the Navy, because had they only built just the one, 1922 would not have been a good year. On the 8th of March, the first DT-1 struck the water and nosed over during a high-speed run over San Diego Bay, which wrote it off, and later on in that year, with less than 7 hours of recorded flight testing aboard, the first of the DT-2s was written off in a landing accident on the 19th of July at NAS Anacostia. Fortunately for Douglas, third time was in fact the charm, and the second DT-2, which made its maiden flight on April the 18th, survived its trial period without incident. This third prototype differed from the first two when it came to the power plant. The radiators, which were mounted externally on the fuselage, were replaced by nose-mounted radiators that were installed within the cowling. Additionally, a slightly more powerful version of the Liberty engine was installed, putting out 450 horsepower instead of 400. This was done to offset the additional weight of modifying the airframe to accommodate the second crew member. Following the initial flights, the only other major modification made during the testing period was to move the oil cooling radiator back outside the engine cowling, as it was found to easily overheat. And with these changes made, the DT-2 completed its Board of Inspection and Survey trials at Anacostia by the end of January of 1923. Even before these trials were completed, the Navy had liked what they'd seen. In competitive trials against aircraft submitted by Curtiss, Stout, Fokker, and Blackburn, the DT-2 was superior in almost all metrics. It was easier to handle, it was easier to maintain, and its steel structure was the strongest by a considerable margin, and they decided to order the DT-2 into production, placing 2 initial contracts for 24 aircraft in total. For Douglas, this being his company's first military design, this was a huge achievement. But they were now faced with a bit of a problem. They had just received an order for a relatively large number of aircraft, 24, and they only had a rented loft in which to build them. To accommodate the new demand, the Douglas company had to very quickly move said production out of said rented loft, and it ended up leasing a new facility on Wilshire Boulevard, an old movie studio which happened to come with a conveniently large field next to it, which was perfect for testing aircraft. Work at the new facility quickly got underway, with 5 DT-2s being delivered by the end of 1922, and the initial orders had been completed by the following year. By mid-1923, the DT-2 was already earning a good reputation for itself within the Navy, and thus for Douglas itself, and the company received a repeat order for 20 more DT-2s at some point in the spring. Additionally, the Lowe Willard Fowler Engineering Company produced 20 more DT-2s under license. During this time, the only major change to the design had been the addition of a newer and larger balanced rudder. This was based on the feedback that pilots required a little bit more low-speed control to improve the accuracy of torpedo attack runs. These changes were made to aircraft already on the production line, and later on they were retroactively applied to DT-2s that were already in service. In service with the US Navy, the DT-2s were flown primarily as float planes from seaplane tenders and shore bases, being operated by 5 different torpedo squadrons: VT-1, VT-2, VT-5A, VT-19, and VT-20. Some DT-2s were also operated from the first US aircraft carrier, USS Langley, to develop free and catapult-assisted takeoff techniques. In May of 1924, DT-2s carried out the first successful launch of an aircraft carrying a torpedo from a carrier, albeit a dummy one for the sake of safety, and in April of 1925, DT-2s were used to test the feasibility of flush-mounted deck catapults. An improved version of the aircraft, known as the DT-3, was proposed by Douglas in 1923, but it was not produced. However, 5 other versions of the aircraft were produced by modifying existing DT-2 airframes for various purposes. The DT-4 was developed by the Naval Aircraft Factory, which re-engined 4 of its aircraft with 650 horsepower Wright T2 engines. These were intended to be used primarily as light bombers, rather than torpedo bombers, but they ended up seeing limited service. One of them did earn a bit of fame when it was entered in a load-carrying aircraft race, where it claimed the fastest lap with an average speed of 115 miles an hour, or 185 kilometers an hour, but aside from this, the DT-4s led a pretty boring life. 2 of the DT-4s were then modified as the DT-5, with the only modification being a geared version of the Wright engine being installed, and the DT-6 was a single aircraft, the last DT-2 to be built in fact, and this was equipped with a 450 horsepower Wright P1, which was a 9-cylinder air-cooled radial. The P1 was a direct forerunner to the highly successful Wright Cyclone, and much of its early testing was done with the DT-6. And finally, there was the SDW-1, which was a long-range floatplane scout developed from the DT-2 airframe. These were produced by the Dayton Wright Company, who took 3 DT-2s, removed the torpedo rack, and deepened the hull to allow the installation of additional fuel tanks. Though the DT-2 had a comparatively short service life with the US Navy, with the type being retired by late 1928, it had done wonders for Douglas's early reputation. Not only had naval aviators adored it for its forgiving handling, but it had become Douglas's first export model when they sold it to Norway. This in turn had a profound effect on the fortunes of the Douglas Company. In 1922, its first year of operations, the company had produced just 6 aircraft for a total value of $130,000. In 1926, just 4 years later, the company's production had risen to 120 aircraft, a 20-fold increase, for a total value of $1.66 million, which was a growth of 1,270%. But this astonishing feat was not the DT-2's biggest legacy, for it was used as the foundation to develop one of the most famous aircraft from the mid-1920s, and one of Douglas's most famous aircraft in general, and that was the Douglas World Cruiser. The World Cruiser could easily claim to be one of the 2 most symbolically important aircraft that Douglas would ever produce, the other being the DC-3. It was also incredibly important to Douglas in general. The World Cruiser became the first aircraft to circumnavigate the world, a feat that became echoed in the company motto and its branding. It would earn the company a huge amount of national prestige, as well as putting Douglas firmly on the international stage, and it would establish a strong relationship between Douglas and the US Army in the same way that the DT-2 did for relations between Douglas and the US Navy. During the spring of 1923, the US Army had begun to show considerable interest in the idea of a flight around the world by a formation of military aircraft. Specifically, they wanted theirs to be the first to do it. Despite the Wright brothers having claimed the world's first heavier-than-air powered flight over 20 years ago, aviation in the United States had lagged behind the rest of the world. Its industry had essentially played the world's biggest game of catch-up during World War I, and in the immediate post-war slump it almost collapsed completely. But by 1923, things were beginning to change. Now, enough people were in positions of senior office that aircraft development was at least being treated as a serious military and commercial matter, and a group of army officers were given the task of planning this global venture. This involved plotting out the route of the journey, organising the vast amount of required logistics for the various stopping points, which involved putting fuel supply dumps in, spare parts, engines, etc., and of course, the officers had to find an aircraft suitable for the task. Very quickly, they realised that none of the aircraft already operated by the air service were actually suitable for this attempt, and they widened their search to look at the entire US aircraft industry. One of the requirements was that the selected aircraft had to be easily swapped between a wheeled undercarriage and floats. Because of this, the War Department organised its team to collect data on various civil aircraft to see which models were most suitable for rapid conversions, and one of the aircraft selected was the Davis-Douglas Cloudster, which was still a couple of years away from its fate of crashing into the sea. But when approached by the Army officers, Douglas declined to provide details for a modified Cloudster, and instead drew up specifications for a heavily modified version of the DT-2, designating it as the DWC, which stood for Douglas World Cruiser. Though designed as a long-distance record setter, Douglas felt that the Cloudster design wasn't up to the task, and that the superior steel structure of the DT-2 would be far more suitable to a journey as ambitious as a full circumnavigation. Additionally, the DT-2 had already been designed with an interchangeable undercarriage in mind, which was one less problem for the design team to worry about. And Douglas claimed that because of this, they could have a modified aircraft delivered to the Army within 45 days of receiving a contract. Having reviewed other submissions, the Army felt that the Douglas proposal held the most promise, and it sent Lieutenant Eric Nelson to work with the company as their representative, whilst Douglas formalised the required modifications for the new DWC. Structurally, there was no need to actually modify the aircraft, but changes were soon required owing to considerations about its fuel load. On the DT-2, a large part of the useful load was taken up by the Torpedo and other military equipment. But of course on the World Cruiser, to give it the necessary range for long-distance overseas legs of its journey, with reserves to spare for obvious safety reasons, the fuel load had to be dramatically increased, and this necessitated a complete redesign of the fuel system. The DT-2 in its original form carried 115 gallons, or 435 litres of fuel. The World Cruiser, on the other hand, was planned to carry 644 gallons, or just under 2,500 litres. This would be achieved by filling every conceivable empty space, not required for equipment or people, with said fuel. There was a tank in the centre section of the upper wing, a tank in each wing root of the lower wing, a tank behind the engine's firewall, a tank beneath the pilot's seat, and a tank beneath the observer's seat. This complex system of tanks, and their necessary fuel lines, was designed by a relative newcomer to the Douglas Company, one Jack Northrop. In fact, the World Cruiser was the first design in which he played a major role, and it kick-started a long and passionate career in aeronautical engineering, one which will be discussed in its own video in the future. Aside from the modified fuel system, which in the wrong circumstances could turn the DWC into the world's largest flying fuel-air bomb at the time, other changes on the aircraft included additional radiators, for use in tropical climates, modified vertical tail services for improved stability in poor weather, the addition of support struts beneath the tailplane, the cutting out of a part of the centre section of the upper wing to improve visibility and nighttime navigation, and the observer's position was moved further forward to improve communication with the pilots. As much of the aircraft was still structurally similar to the DT-2, it didn't take long to build the prototype World Cruiser once approval had been given by the War Department. It was successfully flown and tested in the autumn of 1923, and on November the 27th, Douglas received a contract to produce 4 World Cruisers. By the 11th of March 1924, all 4 had been delivered, and they were each named after a major American city. There was the Seattle, the Chicago, the Boston, and the New Orleans. Once supplies and spare parts had been placed at various locations along the planned route, which included no less than 15 spare Liberty engines and 14 sets of floats, the official start date was set for April 2nd, 1924, with the aircraft taking off from Sand Point at Lake Washington in Seattle. Poor weather and a broken propeller did delay things by a couple of days, but on the 4th of April, all 4 of the world cruisers departed Seattle for the first leg on their journey, which was Prince Rupert in Canada. From there, they flew on to Alaska, stopping at Sitka, Cordova, and Chinook, which I hopefully got the pronunciation correct, where the lead aircraft, which was Seattle, was unfortunately forced to stay behind for engine maintenance. Its poor luck then continued a few days later, when it got caught in fog trying to catch up with the other 3, and it crashed into the side of a mountain. Its 2 crew members, Major L. Martin and Staff Sergeant A. Harvey, survived the accident, and they then had to endure a freezing 10-day hike through blizzard conditions before finally reaching civilization at Port Moller. Meanwhile, Chicago, Boston, and New Orleans carried on. They arrived at Yokohama on the 24th of May, and then they proceeded via Korea, the Chinese coast, Hong Kong, French Indochina, Thailand, and then Burma to reach Calcutta. There, they replaced their floats with wheels and continued westwards across India, the Middle East, southern and then Central Europe, arriving in Paris just before Bastille Day. After a quick hop across the Channel to London, and then northwards, the world cruisers were once again fitted with floats for the Atlantic crossing. Only 2 would make the crossing successfully. The Boston, which was flown by Lieutenant Wade and Sergeant Ogden, suffered an oil pump failure, and it had to land in the middle of the Atlantic. Fortunately, after drifting at sea for some hours, they were spotted and rescued by the USS Richmond. Unfortunately, whilst being towed, and just a mile away from safe harbour at the Faroe Islands, the Boston would be capsized in rough seas. This was not the end of Wade and Ogden's journey though. The prototype world cruiser, which had been held in reserve, was hurriedly prepared to meet them in Nova Scotia. Though they could no longer claim the distinction of making a full circumnavigation in the one aircraft, they could at least carry on the journey with the others. In the meantime, Chicago and New Orleans had completed the crossing of the Atlantic successfully, going via Iceland and then Greenland, and they met up with the newly christened Boston 2. They then travelled across Canada and the United States to much fanfare, and arrived in Seattle to a hero's welcome on the 28th of September. With their wheels firmly on the ground, the Chicago and New Orleans had just completed the world's first circumnavigation by aircraft. From the official start to the official endpoint, they had flown 27,552 miles, which is 44,342 kilometers. Flight time totaled 371 hours and 7 minutes, and the journey was completed across a period of 175 days. The long total journey time was because of a couple of things. There were sometimes stops for weeks, depending on maintenance, supply, and weather conditions, and often there were a lot of press and promotional related events going on along the way as well, which of course added to the total journey time. Owing to their prestigious achievement, it was decided that both the Chicago and the New Orleans were to be preserved, and they can still be found today. Additionally, the Army, who were understandably impressed by the world cruiser, ordered 6 more for use as observation aircraft, and these were designated rather imaginatively as the Douglas Observation Seaplane. These aircraft retained the interchangeable undercarriage of the world cruiser, but had the fuel capacity significantly reduced, as the US was still a few decades away from its pathological desire to send observation aircraft to every corner of the globe, and a pair of 30 caliber machine guns were mounted in the rear cockpit for defense. Redesignated as the 05 in May 1924, they were operated by the 2nd Observation Squadron of the Philippine Aviation Department for a number of years. The combined success of the DT-2 with the US Navy, and the world cruiser with the Army Air Service, solidified the reputation of the Douglas Company with the US military in general, and its work for these establishments quickly grew in scope. Though Douglas himself still aspired towards producing a reliable and hopefully lucrative commercial transport, the value of producing military aircraft could not be ignored, and indeed it was truly realized with the company's next major achievement, the winning of the 1924 observation aircraft competition, which had been held by the Army. This competition was intended to find an aircraft to replace the aging DH-4B, which was an American version of the Airco DH-4. This had the potential to provide the successful company with a steady supply of orders, as observation aircraft tended to be more long-lived and less frequently replaced than combat aircraft, and thus it promised to be a reliable source of income. Earlier in the year, Douglas had been awarded a contract to produce 2 prototype aircraft, both known as the XO-2, to submit into this competition. These were identical except for the power plant, both of which were liquid-cooled V-engines. Due to a large number of surplus Liberty engines, of which an excessive number had been ordered during the First World War, but were mostly not delivered until hostilities were all but over, the War Department had insisted on aircraft being designed and tested with this engine first. The second XO-2 was to then be powered by a competing V-engine, which was the 510 horsepower Packard 1A-1500. The Liberty-powered XO-2 was first tested by Eric Springer in the autumn of 1924, after which it was delivered for competitive trials at McCook Field. During said trials, it proved to be significantly faster than the DH-4, the aircraft it was designed to replace, and in general it performed much better than the other competing aircraft submitted. This resulted in a unanimous recommendation by the evaluation board to adopt the aircraft for service, and Douglas subsequently received its single largest order to date, requiring them to rather quickly produce 75 aircraft known as the Douglas O-2. This would be the start of a long line of observation aircraft built by the company. Between 1924 and 1936, the Douglas Company, and then the Douglas Aircraft Company, a switch which we will get to later, produced some 879 of these aircraft across a staggering 50 different variants. The Douglas observation planes would be among some of the most important types of US military aircraft built in the interwar period, and they were by far and away the company's biggest financial success until the arrival of the DC-3. Now, for reasons that mostly involve keeping this video to a reasonable length, I won't cover all of the O2 variants in detail, but we will take a look at some of the honourable mentions. Firstly, we have the original, the O2. Though an order for 75 was placed, only 45 would be delivered to this original specification. They were generally identical to the XO-2, but they had a simplified engine installation with a large, modified tunnel-type radiator, which was mounted further back behind the propeller shaft. Additionally, the engine now produced more power, 435 horsepower versus 410, and in its original configuration, the O2 was good for a maximum speed of 128.5 miles an hour at sea level, or roughly 207 kilometers an hour. In terms of armament, the O2 came with a fixed forward-firing 30 caliber machine gun, a second mounted in the rear on a flexible mount for defense, and it could carry up to 4 100-pound bombs on underwing racks. Its non-standard equipment could also include the installation of additional machine guns, one 30 caliber over each lower wing, smoke dispensers, and in some cases, photographic equipment for reconnaissance and surveys. Within weeks of the first O2s arriving, other variants began to follow suit. The O2A was identical to the O2, but also came with night-flying equipment, and the O2B was a command aircraft fitted with dual controls, one of which was used for some time by the Chief of the Army Air Service. The O2BS was a one-off design that was ordered by pilot James McKee. His intention was to make an attempt at the first single-pilot, single-aircraft trans-Canadian flight. For this, all the military equipment of the standard O2 was removed, and the landing gear was swapped out for amphibious floats to take advantage of the countless lakes and rivers dotting the Canadian wilderness. The attempted flight was a success. Between the 11th of September and the 19th in 1926, and with the help of Canadian authorities, which provided all necessary support and logistics, and assisted by squadron leader Earl Godfrey as liaison officer and navigator, McKee flew the 3,000 miles, or 4,800 kilometers, between Montreal and Vancouver in just under 36 hours, at an average speed of 85 miles an hour, or 137 kilometers an hour. Following the O2C, of which 46 were built, which came with a new flat radiator, the next major variant was the O2H. This version could almost be considered a completely new design, but the O2 designation was nonetheless retained. It had a revised fuselage structure, new tail surfaces, a streamlined undercarriage, and it had new staggered wings of unequal span. Unlike previous versions, these wings did not house any fuel tanks, and all of the fuel was now stored in a single tank between the cockpit and the engine. A total of 140 O2Hs would be built, and along with the aforementioned changes, they were also notable for being the first to make the switch to all-metal propellers. After this came the O2K, which was an improved version of the O2H, with 37 being built for the Air Corps and 20 for the National Guard. But the K was most notable for its role as a training aircraft. 40 would eventually be modified with dual controls and redesignated as the BT-1, or Basic Trainer 1, not to be confused with the short-lived Northrop BT-1 dive bomber. Thankfully, the two were quite easy to distinguish. One was a biplane, one was a monoplane. One handled like a dream, according to the pilots. The other tried to kill you if you tried to roll the aircraft over. That being said, the Northrop BT-1 would redeem itself when it was eventually redesigned into the Douglas SBD Dauntless, but that is a topic for later discussion. Eventually, other Douglas observation aircraft would be converted into trainers as well, or have their designs modified to be built as dedicated trainers from the outset, with the list including the BT-1, the BT-2, the BT-2A, the BT-2B, the BT-2BI, the BT-2BG, the BT-2BR, the BT-2C, the BT-2CI, and the BT-2CR. These designations admittedly covered general flight trainers, instrument trainers, and radio-controlled aerial targets, but in general they were variations on a theme. All of them were very successful in their own right, and all of them led active but fairly unglamorous duties in either providing training opportunities or quite literally training the future pilots of the American Air Forces. Another offshoot developed from the O2 observation aircraft was a series of mail planes that began with the DAM-1. In 1925, the US Postal Service negotiated with Douglas to develop a replacement for their fleet of modified DH-4s. At a glance, this new aircraft looked almost identical to the O2, but there were actually some major changes. All of the military equipment was obviously removed, though the concept of an armed and aggressive postal service is as hilarious as it is terrifying. The observer's cockpit was deleted, and the pilot's cockpit was moved further back. This allowed the installation of a fireproof compartment that could store approximately 1,000 pounds, or 450 kilos, of mail. The first of these modified mail planes flew in early July of 1925, after which it was leased to the post office for a year so that they could evaluate its performance across the seasons and in various weather conditions. It was operated primarily on the Illinois-Nevada section of the transcontinental mail route. Equipped with 150,000 candle power lights and parachute flares for night operations, the aircraft proved to be faster, more capable, and more reliable than the old DH-4s. They also handled poor weather better, and they were in general considered easier to fly. The type was then ordered in quantity by the post office as the M3. 10 of these were produced, and they were soon followed by an order for 40 M4s, which had an increased wingspan of 44 feet 6 inches, compared to the 39 feet 8 inches on the original, which for those of us on the metric system is a difference of about 1.5 meters. Unfortunately, the M4s would barely get any service before the majority of the air routes were privatized, and many Douglas mail planes found themselves up for auction. Some found themselves in the hands of the Army Air Corps, and some were purchased by the National Air Transport Company. Others served for a time as combined airmail and passenger transports, and the M2 variant was specifically ordered by Western Air Express for this very purpose. Their commercial use was short-lived though, as the introduction and then the mandating of multi-engine aircraft for transport duties soon relegated most of them to the scrap heap by the early 1930s. Getting back to the observation planes, a change in the wind came with the O-25C. It was the last of the Douglas observation aircraft that was to be powered by a liquid-cooled engine, and it also reflected a general shift in the aviation industry of the United States. Across the board, the air-cooled radial engine was rapidly becoming the dominant power plant of choice. The most notable of the radial-powered O-planes were the various derivatives of the Douglas O-38. With the exception of a few individual examples, these were all powered by the 9-cylinder Pratt & Whitney R1690 Hornet, and somewhere between 155 and 168 were built. Sources do conflict on the exact number. Of these, the O-38F was to be the last War Department designated version that Douglas built. Produced as an unarmed transport with an enclosed canopy, it was delivered for use within the National Guard. The National Guard, in fact, is where the O-planes earned their best reputation. By 1926, at least 15 National Guard observation squadrons were already operating the Douglas O-2 in some capacity, and in later years they received various later models, depending on their operational requirements. Some of these aircraft would come straight from Douglas production lines as a direct order for the National Guard, while others were hand-me-downs from the Air Corps as they upgraded to more modern monoplanes, some of which would still be built by Douglas. Despite the rapid march of technological progress during this time, they were not phased out of the National Guard inventory completely until 1942. This was because they were very easy to fly, a quality that is echoed by every pilot who has essentially touched one of these aircraft, and more importantly for the National Guard, they were very easy to maintain. The National Guard's air units had nowhere near the sort of logistical support that was found within the Army Air Corps, and having an aircraft that was easy to maintain was far more important than having one that had all of the latest technology. These observation aircraft, operated for many years by both the Army and the National Guard, formed the bulk of Douglas's production in the mid to late 1920s. So much so that the company's other aircraft developed during this time period are almost completely forgotten. In fact, from the standpoint of personal ambition, the success of the O-2 and its derivatives actually prevented Douglas from achieving his original goal of producing a successful transport, at least in the short to medium term. During this time, the company's limited engineering staff was kept perpetually busy with military design work, both in drawing up new designs and modifying existing ones to the needs of the Army, the Navy, and the National Guard. This understandably limited the amount of man-hours available to work on civil designs, and this was further compounded by the fact that Donald Douglas, like several others of his peers in the early 1920s, had grossly underestimated how rapidly competitive the private and commercial markets were becoming. His first attempt to break into the private market came with the Douglas Commuter. Like several other designers, Douglas believed that a large number of ex-service pilots from the First World War would want to continue flying, and he predicted a booming market for light and inexpensive private aircraft. In response to this, he designed a small two-seat aircraft that could either be powered by a 35-horsepower 3-cylinder Anzani or a 60-horsepower Wright Gale. This aircraft, Douglas's first monoplane design, had high-mounted externally braced wings, which could be manually folded along the fuselage, so that the whole thing was slim enough to fit into a common garage. Built primarily of wood, with fabric coverings, with the exception of the engine cowling, the Commuter was meant to be easy to assemble, and able to be produced from a simple workshop. The prototype first flew in January of 1926, but even though test pilot Eric Springer said that it handled well, it would remain the only example of the Commuter to be built. Competition was exceedingly fierce in this new market, with countless light aircraft being designed and tested in the early to mid-1920s, and Douglas couldn't justify neglecting his military obligations to further develop the Commuter into something more competitive. A similar fate befell the Douglas DA-1, also known as the Douglas Ambassador. Like with the Commuter, Donald Douglas went with a monoplane configuration, except this time he went with a parasol wing. Design work began in 1926, but things progressed at a glacial pace because Douglas had to prioritize the production of all of their military aircraft. In fact, most of the work on the DA-1 was done in the off-hours by Douglas himself and a small team. Unlike the Commuter, which was still going through its flight trials at this point, the DA-1 was conceived as a vastly different machine, with an emphasis placed on sturdy construction and reliability, rather than on low manufacturing and operating costs. As such, the DA-1 was built of mixed construction. The fuselage was made from a light steel framework and clad in a mix of plywood and fabric. The wings were built up from spruce and had a plywood covering, except for the control surfaces, which were still fabric covered, and it was powered by a much more powerful engine, a 220 horsepower 9-cylinder Wright Whirlwind. Though it was superior in general to the Douglas Commuter, the DA-1 would also only exist as a single aircraft. Additionally, it almost deprived the company of its founder. After attending the El Paso air races in late 1928, Eric Springer and Donald Douglas went to fly the DA-1 back to their factory in Santa Monica, but the DA-1 crashed on takeoff. Fortunately, both men walked away unharmed, but the aircraft was written off due to extensive damage to the undercarriage and lower section of the fuselage, and no attempt was made to build a replacement, as Douglas wanted to focus on producing more aircraft for the Army Air Corps. These early failures at civil aircraft didn't deter Donald Douglas, but they certainly helped him to further appreciate the value of successful military contracts. This is further highlighted by the fact that his only successful transport design from this period was one that had been produced for the Army, and that was the Douglas C-1. Produced about a year before the failed Commuter and the DA-1, the C-1 was designed to meet a War Department requirement for a large single-engine transport. These were similar in construction to the Douglas World Cruiser and the O-2 biplanes. The fuselage was built from welded steel tubing, with the forward section clad in aluminium and the rear in fabric, while the wooden wings now featured a metal leading edge. The C-1 was designed to accommodate a pilot and a co-pilot, which were sat abreast in an open cockpit, along with up to 8 passengers in an enclosed cabin immediately behind them. Alternatively, the passenger seats could be quickly removed, and the C-1 could be used as a cargo transport, with a maximum load of up to 2,500 pounds, or about 1.1 tons. The first C-1 made its maiden flight from Santa Monica on the 2nd of May 1925, completing its service trials by the end of the month. The initial order for the C-1 was for 9 aircraft, and all of these were delivered by the end of the first year. One of these was used as an experimental testbed for a time, being equipped with geared Liberty V16-55 engines, and being redesignated temporarily as the C-1A. For several months it was tested with various undercarriages and engine cowlings, including the installation of skis for winter operations, before being returned to standard C-1 spec at some point in late 1926. Plans were drawn up for an improved version, known as the C-1B, which was never built, but the War Department did place a follow-up order for 7 examples of the C-1C. This version had an increased wingspan, new exhaust manifolds, and a slightly modified undercarriage. It was also now designed to be used as an ad hoc medical transport as well, as internally there was now provision for the carrying of up to 4 stretchers. In service, the C-1s and the C-1Cs were attached individually or in small groups to major Army airfields, rather than being assigned to specialized transport squadrons, as for their type they were still quite small. 10 additional C-1Cs were ordered and delivered in 1927, after which they led a successful but ultimately mundane life, with the only exception being a C-1 that was used for early aerial refueling tests in 1929. By the time the last C-1 was completed in 1927, the Douglas Company was almost unrecognizable from the small enterprise that had started just 5 years earlier. In 1922, Donald Douglas had scrambled to organize a $15,000 loan to get things up and running, and yet in a few short years, his company boasted almost $2 million in net sales for the fiscal year of 1927, and since its inception, it had now delivered just under 300 aircraft, which for a company operating from a disused film studio wasn't bad work at all. Along with producing the aforementioned designs, the Douglas team had also cut their teeth with twin-engine aircraft, assisting with, or outright taking over, the work on the twin-engine T-2D Torpedo bomber. a design which was originally conceived by the Naval Aircraft Factory. They were also gearing up to work on the PN flying boats, another design by the Naval Factory that would be built by Douglas engineers en masse. Though not designed by the Douglas Company itself, these two aircraft would provide the engineering team with much-needed experience on twin-engine aircraft design, something that would soon serve them very well with future endeavours. By this point, Douglas now employed several designers who would go on to achieve fame either within the company or with others in the future. Among those on Douglas's payroll was Arthur Raymond, whose name would be immortalized a decade later when he led the team that designed the Douglas DC-3 airliner. Another designer was John Jack Northrop, who first worked on the World Cruiser, and who would bounce between Douglas and Lockheed for the next few years before forming the Northrop Corporation, which would begin as a Douglas subsidiary. And yet another Douglas employee at the time was one James Dutch Kindleberger. He would go on to work on the DC-1 and DC-2 airliners, but is most remembered for his work at North American Aviation. There, he led the team that designed the P-51 Mustang, transforming the company's fortunes overnight and kicking off a long and highly successful career. But all of these achievements happened in the next era of Douglas aircraft, for the time of the Douglas Company was rapidly drawing to an end. By mid-1927, production was increasing at such a pace that the facilities of Douglas's Wilshire plant were very much struggling to keep up. Additionally, space was becoming a big problem. Not only were aircraft being crammed here, there, and well, everywhere, often being parked outside under basic canvas coverings, but the adjacent grass field wasn't big enough to test newer and more powerful designs. This meant that new aircraft were having to be towed from the plant by night to Cloverfield, which was about 2 miles away. For the occasional aircraft, this wouldn't have been too much of a problem, but still inconvenient, but as the production numbers rapidly grew, this nocturnal practice soon became completely unsustainable. Douglas's lease of the Wilshire facility was due to expire in 1929, and with no room to expand, it was clear that the company had to find a new home. In its short but successful time of operations, Douglas had become quite the financial asset for the city of Santa Monica, and not wishing to lose said asset, the city made Douglas an offer. They were prepared to cooperate with Douglas to expand and update the facilities at Cloverfield if Douglas were to build their new factory on the adjacent land. Douglas was more than happy to agree with this proposal, but the required capital to build a new facility was currently beyond the scope of his business. Up until this point, the capital of the company was controlled by Douglas himself, Bill Henry, and Douglas's father, William, who had joined the company and brought in his financial knowledge from a career in banking. By the autumn of 1928, all but $40,000 of the net profits made since 1922 had been reinvested in the company, and as a result the net worth had risen to $2.5 million. In cash, the company had about $1.4 million, which wasn't enough to build the facility that Douglas wanted, and after consulting with various financial firms, Douglas decided to completely restructure his company into something new so that he could acquire more finance to get things rolling. And so, on the 30th of November 1928, a new company, the Douglas Aircraft Company, was formed. This new company was supplied with additional finance, and it was divided into 1 million shares. 300,000 of these were directly issued to Douglas Aircraft, of which 200,000 were used to purchase the assets of the old company, and the remaining shares were sold to the public. Approximately 2/3 of the shares put money straight back into the company's cash account, to the tune of around 650,000, and the rest was used to set up Douglas's new production facility on the fringes of Cloverfield. Completed in 1929, this new facility took up just under 8 acres of land, and combined with the upgraded facilities at Cloverfield itself, it provided the Douglas Aircraft Company with a strong foundation for growth and development. The Douglas Company had only been in existence for about 7 years, but its successor would see almost 4 decades of operations before it too would restructure, merging with McDonnell to form McDonnell Douglas. The 4 decades leading up to that merger, though, were full of ups and downs, huge successes and some dismal failures. good luck, bad luck, a Great Depression, a World War, and some singular design thinking that was often coupled with a surprisingly poor appreciation for the commercial market, which was a surprise considering Douglas's early aspirations. But all of that is to come and will be discussed in the second and third parts of this video series covering the history of Donald Douglas and his company's aircraft. As always, thank you all so much for watching, and a big thank you of course to the patrons who voted on today's topic. And again, I am so sorry that it is so late coming, but as you can see, it is a much longer video than I planned, and I'm already losing my voice. Obviously, I did not record this all in one hit, that would be insane. A big thank you, of course, to our Wing Commander tier patrons, our highest tier supporters. And now that these videos are going up, I will put a new video poll up on Patreon in the next coming days, and I would also really just like general feedback on this type of video format going forward. I know people like the long videos, but do they like the really long videos? That is the question. But, as always, thank you all so much for your continued support, and I will catch you all next time for part 2. Goodbye.